Hey students, welcome back to this wonderful chapter, Chemical Kinetics. In this conclusive module of the chapter, we are going to study the second part of collision theory. We have already seen the basics of collision theory and a couple of postulates related to it. The first thing that we saw was that the reactant molecules have to collide in order for a reaction to happen. That's pretty well understood. Second postulate was that the energy of collision should be equal to or greater than the activation energy. Now here we had seen Arrhenius equation and we had tried to replace A, the Arrhenius factor, with frequency factor. But it didn't work out in case of complex reactions. Here is why. Because for complex reactions, there is another factor in addition to the collision and the energy of collision. There's one more factor, and that is orientation of the reactant molecules. Consider this reaction AB plus A2B giving AB2 and A2. Now here I have the reactant molecules with me, AB and A2B. When they collide, you can see it from the orientation that when the products will be formed, the collision will not be effective. It will be an ineffective collision because the reactant molecules are not oriented properly. You will still get AB and A2B. But if I take this A2B molecule and I flip it around like this, now if I want AB2 and A2, now this can happen. Watch this. The collision, when it takes place, now you can have AB2 and A2, which will be separated out. So this kind of a collision will be effective because it has happened in a proper orientation. You have already studied such example under SN1 mechanism, where you have OH minus ion. When it collides with the bromine atom of methyl bromide, no products are formed because that orientation is not proper. However, when this OH minus ion, it attacks methyl bromide from the back side, we call it a backward attack. Now when this backward attack takes place, you get methanol and bromine ion. So yes, proper orientation is required for effective collision. Now, along with this, there's one more factor called as potential energy barrier. Consider this reaction right here, B plus AC giving an activated complex BAC. Now this BAC gets converted into BA plus C. Here's the energy profile diagram. This energy profile diagram explains the energy of reactants, products and the activated complex. Now it's pretty much obvious. When the reaction is taking place, the energy of collision, it comes from the kinetic energy of the colliding particles. These colliding particles are coming together. They are colliding with some kinetic energy. Now, when they collide, this kinetic energy of the colliding particles gets converted into potential energy in the activated complex. And this is where we have a transition state. Now, this potential energy that the kinetic energy has converted into, this potential energy, it should be sufficient in order to cross this energy barrier. So, we say the transition state is like a potential energy barrier. If the potential energy is able to cross this barrier, the reaction will take place, the collision will be effective. So these are the two factors, orientation of the molecules and the potential energy barrier. So we can say in conclusion that for effective collisions, number one, the collisions should happen with sufficient kinetic energy, and number two, the collisions should happen with proper orientation. Here we can rewrite our equation as K is equal to Pz into e raised to minus Ea upon RT. So we have added one more term here, P, and this P is nothing but steric factor or probability factor. It tells us about the proper orientation of the molecules in the reaction. So here if I compare it with Arrhenius equation, K is equal to A into e raised to minus EA upon RT. Now I can say that A is nothing but P into Z. So it's called as frequency factor or the pre-exponential factor. So A is not just the frequency of collisions, it's actually a product of frequency of collisions and the probability factor. So this is collision theory for you. That's all for this topic. With this, we come to an end of chemical kinetics. I hope you've understood this chapter. Thank you very much.